Now let's go back to the ANOVA assumptions for a second. We assumed that the samples are random and independent. We assumed that the response variable values are normally distributed, and then homogeneity of the variance, which means the populations all have the same variance. Now we can verify whether this assumption is valid or not by using a test, and this can be tested using what is called the Levene's test. So here the test is whether the variances are all the same in the null hypothesis as against not all of them are equal. Okay, and we perform this test by first computing the difference, the absolute difference of each observation from the median. Okay, so we have to transform the sample into each sample observation as a difference from the median, absolute value of the difference. So the positive, there are no negatives, they're all absolute values. So here club 1, if 251 is the midpoint, that's the median. So the difference between the median and 237, absolute difference is 14. Here it is 10. Here the difference is 0. And here the difference is 3 and 12. And repeat that for club 2 and club 3, golf clubs. Now you run the analysis variance procedure on this transformed data. Okay. Then if the p-value is less than or equal to 5%, then you'll reject the null hypothesis that all the variances are equal. Otherwise you will not reject. So this is the basis for the test, and let's go to Excel and complete the test. Okay. So step 1 is transform the sample observations to absolute difference from the median. Step 2 is run ANOVA. So first thing is we have to find the median, and Excel gives you a very easy way to find the median. This is median of the sample, which samples are given here. Okay, so that's your median, and you copy that across to the rest of the columns. You get the median for each of the samples. Then you find the absolute, okay, ABS, absolute value of the difference. So you take the first sample minus the median for that sample, which is this. Now we have to use the absolute cell reference in a judicious way. So if you press F4, that puts dollar signs for both the column reference as well as the row reference. So when you copy down, $99 will make sure that the median always comes from row 99, which is a good thing going down. But when you copy across from in aisle to the front, now since you have a dollar sign for C also, the median will continue to come from C99. We really need the C to change to D. So there should not be a dollar sign for the column reference C. So we press the F4 key again. So now the dollar for C is gone. And if you press F4 again, the dollar from 99, the row reference will be gone. C will get the dollar back. And if you press the F4 key one more time, then we are back to square one where we started with. So let's go back once. That puts dollar sign for both, and one more time that puts dollar sign only for the row and not for the column. That's what we want. So now close parenthesis. Now you copy that down. Okay, so that gives you the absolute difference from the median for the first sample. Let's put the border back here. Then if you copy this across, okay, make sure that the median changes corresponding to the column D99, E99, and so on. So here is the transformed samples. Now we can run the ANOVA command to generate the ANOVA results. So single factor. Now we're going to use the transformed data, which is that. Okay, and we'll put the output here. click OK, and format. Okay, now the null hypothesis is all the variances are the same. Alternative is not all the variances are equal. Yeah. Let's just look at the p-value approach. The p-value is that. We'll express that as a percentage. So it's greater than 5%. So we cannot reject the null hypothesis. That means our original assumption that the variances are all the same is okay. So do not reject. And the interpretation is we do not have sufficient sample evidence to conclude that the variances are unequal. If we concluded they are unequal, then the probability of type 1 error is 39.5%.